Hi everyone, and welcome to another tutorial by G. In this tutorial was actually a question from one of my friends. The question was this. This was a scene that was also in internet, in a forum, and the whole thing is done with scripting. And he asked me if there is possible to create the same result, but not using the scripting in the particle, but instead of using scripting, using Dataoperator. So I tried to create the same result but with Dataoperator, and as you will see, it is very easier and more powerful, and so I thought myself it's good to share it with all of you. As you can see here, if I press 6, the scene, you can divide the whole thing in two sections. The first section is one particle. This particle is actually, if I unhide it, we have a box here as our object instance, and here he has created 26 particles, and he used the position of the vertices and the normals of the vertices, and located the particles that are in a form of a box there where they are belong. And also after that he used a scale override to make it a little bit taller and thinner. So, and here what he had done, he used actually a script for this part, and this script, as you can see, he used the get vertex function to get the current vertex position and assign it to this variable, and also he get the normal with the function get normal from the current particle and assigned it to this variable, and he assigned both of these variables to the matrix position of the particle. And in the second part, you can see that we have some particles that are emitting from the icon, and after that we have a script, and in this script you have the same thing. We have once again the position and the normal, and here he used this position to pass the position as a script vector to define target. As you can see here, what he had done, he created here a use vector. Use vector is actually empty place where you can store a vector information, and use matrix is also a same empty place where you can store empty matrix. So, and after this he had go to rotation, which the function go to rotation works so that after the go to rotation you should give a rotation to the event, and it tries, for example here in 55 frames, it tries to reach the destiny, or he tries to get the final rotation. And here he used here once again another script for applying the rotation, and you can see here that he first tried with the rotation part, but you can see it's not working here, and he has wrote here that I can't make it work using the particular origin properties, so he used it with matrix. So we will create the same effect, but not with scripting, but with with Dataoperator. This is my scene that I have created, as you can see, and you can see that it's the same result, but if I press 6, you can see that I have now scripting here. It's just data operator and data operator, and once again data operator. So for this, let's begin. I have my instance box, I hide this. I also hide my sphere, and I go to the frame 0, select all of them and delete them. Very easy. And I press 6 because we have this stuff here, and I delete them here too. Delete. So now everything is empty. So we want to begin from scratch. We have a sphere, is 8 segments and 1 box. So first I create a PF source, and let's assign, for example, here is a good position, and let's begin. The first thing that I want to do, I select my PF source, say frame, and I want to have 100% viewport. This is very important. The second thing is that I want to have start and stop at 0 and just one particle. I delete, I want to use shape instance, and I bring this here, and where is my shape instance? And I want to have my box as my shape instance, and I select my display, and I want to have it geometry. Okay, the next thing that I need, I delete this speed because I don't need any speed and any rotation. But what I want to what I need, I don't also need the position. What I need is just data operator, and in this data operator, what I want to say is this. Okay, make it so that I can see the scene at the same time. First, I need the select object. I need this object, my sphere as my object, and I go here to geometry. So, and what I need is here number, something like this, number of face number of object number vertices. Okay, so I get the number of vertices and I apply it as the amount change. So right now, if you can see, we have 26 particles because we spawned 26 particles, because here we have 26 vertices. The next step is to get the position. For this, I once again bring a geometry, and this time I say I need vertex position, and here I assign it to the sphere, and I bring an input standard because we have to say which particle, the first particle to the first vertex, second particle to the second vertex, and so on and so on. And what we want to do here, we want to have it as output standard and as a position. So we have right now here the positions, okay, and we need also store this position for the next particle PF source that they want to come into, they want to follow with the find target. So we want to store this information, this here, for later using it for the final for the find target. Okay, so therefore I create an input custom. Sorry, I create an output new, and this output new is global, and it's a vector, and I rename this to output vector. Okay, and I put it here. So but the problem is that we need the normal of the vertices, so we can apply it as a rotation to the particles. So how can we do this? This is a little bit complex, but it's the same. Once again, I bring a geometry, and this time instead of using vertex position, I use vertex normal. And once again, I apply it to from the sphere, and which vertices at each time the birth index. So we have right now the normal, but this normal is a vector. So how can we apply it as a rotation? I bring an input standard, and I use the matrix, transform matrix. Right now, because we have no no position here, this matrix is full empty. It's nothing there inside. Okay, I bring a function, and in this function, what I want to say is from vector to matrix. Okay, and I apply. Connect this here to here, to here, to here, and as an output standard, what we want to have as an output is the matrix. Okay, I select this here, and you can see delete. Right now it's wrong because the output is a vector, because the function is wrong. What we need is align matrix, second matrix, the z-axis to the vector 1. Okay, so this is in this position, or in this case, what we have the matrix, which the matrix is in the origin, is in the 0, 0, 0, while we haven't defined any position for the particles, and tried to get a vector and try to align the object in the z direction, in the direction of vector 1, which is this here. So but when I apply this to here, you see that it disappears. I select my sphere and hide it, and you can see that they are all here. The direction is right now right, but they are here. Why? Because we have here just the information of the rotation and not the position. So how can we fix this? So we have just to change the order. Okay, we have to say, okay, first calculate, okay, first we have the span, okay, in the execution order, and in the second execution order, first calculate our matrix, and after you calculate the matrix, then you apply the position. So here we are. Now we fix this. Okay, so and we also need to store the matrix for the second particle. So how can we do this? In output new, and this output new should be a matrix, and I connect it to here, and I make it global and rename this to output matrix. Okay, and at the last thing, we want to have all this happening just in the first frame. So as you know, we should filter it. I create an input standard, make new in event, and I put it as filter to here, and to here, and to here, and where else, position vector, and to here, and to here. So all this stuff, all these 5 stuff that is we have here all this will just apply in the first event, in the first event in the first frame. Okay, so far what we have is this, and after this I apply a scale just to have the same result as the original file. Okay, where is my scale? Okay, I bring the scale and make it 50, 50, 150 or something like this, or what is 100, I don't know. Okay, no problem. So first, this is what we get until now, and now we try to move to the second part. Okay, I create once again a PF source, and I try to align it to the first one, the same position. Okay, and from here let's begin. I select my PF source, frame, get issue, it's viewport 100%, and go to the stop and start and stop to 0 and 40, and we want to have 26 particles. Okay, and we want to emit them from the position icon. That's okay for us. And what we want to have is rotation, so we need the rotation, and for the rotation we need speed space, and let's have it geometry. And I also need the instance, shape instance. I copy this here and I bring it here so we can see. Right now we can see that. And I also need a spin, and the spin should be particle space. And okay, that's right. So they're rotating in the Z and local Z direction. Okay, and we have also shape instance, and in the end what we need, we don't need speed here, because we have all actually a find target. So find target. Okay, find target, and in this find target should go to the next event. Here apply it as geometry, and we have here find target. Okay, so in this find target, what we want to say is we want to have it controlled by speed, and the speed should be 150, and the variation 0, and we have a mesh object, add the sphere, and all here we go here, and for direction we choose icon spherical. Okay, I go here to rotation and try to rotate them so that they are towards the sphere, but you can see right now that it's somehow working. But what we need here actually is we need here the script by script vector. Okay, and for this we should give the computer the script. Okay, so I create a data operator above the find target, make on the auto update, and open it. Okay, here I select an here I need my input custom, and this input custom will be my input output vector. Okay, this is my input, and I will apply this as output standard, as a script. Okay, as a vector script, and this should just happen just in the first frame that the particles are coming into this event. So for this, input standard and new event. But so far so good, and you can see that it should work, but it didn't work. Why it's so? Because we have defined these variables, I mean this output vector and output matrix, in another particle flow. So you can use this in another particle flow, but you should tell the computer, okay, how to do this. I bring a select object, and here I say PF sources, my select, and I say okay, select my first PF source, and here I select this and I say, hey, I need this variable, but not from this particle, but it's from another particle. So it's working. I select this and you can see a slide. Yeah, so they are, yes, they are following and trying to go to this position. And here what we want to do, we need here go to rotation, and as I told you before how this go to rotation work, you give a duration, for example 55, and deselect, and it tries in 55 frames to match the rotation to the rotation that you applied after this command. And so after here we should tell the computer what is our desired destination for the rotation. So how to do this? Once again, in the original file he used the script, and here we should use the Dataoperator. So once again I bring a Dataoperator here, auto update, and okay, once again I bring and select object because it's from another event, PF source 1, and after this what I need is an input custom, and our input is our matrix, and I select this, say okay, I want to have this matrix from another event, and I need an output standard, and in this output standard what I want to have is a rotation, okay, quaternion rotation, and I have here matrix and here a quaternion, okay, but I connect this, and here we have a converter. A computer is smart enough, okay, you could do the converter by your hand, it's no problem. And another input standard to tell the computer that I want to have it just once, okay, new in event. So I have my final destination as my rotation information, and after this what we want to say is okay, right now find target, another find target, and we want to say okay, after this go to another event, okay, and this another event, okay, not by speed, by time, and with this time we need time in 60 frames, okay. And once again mesh objects, and I add my sphere, go down instead of random by script, because we still have our vector information. It's the same information that we used here, and here icon spherical. So, and because we don't want them to continue their movement, so I select the speed, make a speed to 0, and I connect this to here, and I connect this to here once again. It's 0, but get sure that we see the geometry. So what we have right now, that there are the particles. There was something that I forgot, and that was in the first find target we should instead of telling that if they are less than 1, because normally it's here 1. It says when the particles are near or less than 1 unit to the target, they should go to the next event. We don't want to come so close to the destination, so we should say that 100. Okay, so when they are in the 100 unit of the destination, they should go to the next event. That is something that I forgot during the capturing this tutorial. So that is right now, so that the particle trying to come, and when they reach the area, they go to the next event, and in 55 frames they have time to have their right rotation, and then they come to their final destination. So this is it. This is the whole tutorial about. So we did the same thing, okay, nothing new. This is, you can find this scene, but not with Dataoperator, but with scripting. So what I teach in this tutorial was how to convert or translate a scripting file to a Dataoperator file. Okay, I hope you enjoyed this tutorial, and I hope that you learned something. If you like my work and my tutorials, don't forget to subscribe. And as you saw, this tutorial was a question of one of my friends. If you have any question like this, that you want to solve something and you cannot, or you need help, feel free to mail me or ask me in YouTube. So bye for now. Have a nice day.